be available on our YouTube for anyone who might have missed it or want to hear what goes on in one of these sessions. It'll be posted on our YouTube later today. So we're using a ground fault locator to identify nicks and cuts in a buried wire. Pretty important function. A lot of folks have not used this as much as they've used locators and other kinds of test equipment, but it is a very useful device in situations where you might be stuck. And being stuck by that, I mean you can't see where the cut is, and you've obviously got cable damage. So what we're going to cover today, we'll try to identify when you should use an electronic locating tool like this, and we'll understand how this thing works, what kind of principles are involved, and then we will talk a little bit about the limitations and the benefits of using this. This kind of device is one that I have often had customers describe as something that you only use 3 or 4 times a year, but those 3 or 4 times they save them days in troubleshooting trying to find a problem. So that's the background for this situation. The equipment we're talking about, a locator is always necessary for troubleshooting, and in the case of this device, no exception. The locator is required to find the path of the cable that we're trying to troubleshoot, and then the ground fault locator is used along the path to try to identify the source of the problem. The GFL 3000 is the one that our Armada makes. Some of you may already own one of the older progressive PE 2003s, very similar device, also known as an A-frame. Some of the more expensive locators out there have this function as part of them, and you may find that you also have an A-frame with a 3M Dynatel, one of the larger locators that they make. But the A-frame is the function we're talking about here, and pulsed fault location is what we're doing. So when you use one of these locators, anytime you have a fault in the cable and you cannot see it, it's obvious that there's something going on. The ways that you find out these things are going on, one of them is the controller just quits. It refuses to connect voltage to the system anymore. Very common kind of a fault you see in 2-wire systems. The controller is smart enough to know that too much current is going on the line, so it shuts off and shows you a fault code. You can also, in your troubleshooting, have used a high resistance meter and measured the resistance from the wires in the cable to the earth and found out that it's less than half a megohm. You may have a semi-short or ongoing short into ground that is maybe not causing you a problem, but certainly will because of corrosion. Sometimes you go to the far end of the cable and you hook up and you have no resistance, no voltage or anything under any condition. It's a sign that the cable's been cut. You're using all this kind of Ouija board stuff to try to figure out if something's wrong with the cable in the first place. So I suggest that you always look for the easiest way to try to find the trouble. And eyeball, Mark 1 eyeball is always the first thing. Walk the path of the cable and look. If someone has planted a 36-inch box tree right in the path of the cable, then you don't need to do a lot of sophisticated troubleshooting. If you find that the cable TV guys just plowed a new drop up to the house right across the path of your cable, you can be suspicious that that's the place where it's happened. But if you can't see it and it's out there somewhere and you really are having trouble spotting where it might be, you may be forced to resort to the ground fault locator, which I can tell you almost always finds the problem. There are other troubleshooting tools like that clamp meter there. If you have a faulted condition in a 2-wire irrigation system, you can use the clamp meter to try to identify where the current goes. But I can tell you that probably the fastest thing to do is get out the ground fault locator, and it'll lead you right there. You don't have to search through 10 different valve boxes to try to locate the problem. The kinds of things that happen that you may not be able to see from the surface, insulation chewed off by a rodent. Everybody's probably seen this situation where a ground squirrel or gopher or some other kind of an animal has been tunneling. They like to go where the dirt is softest, and naturally the dirt is softest around where you buried your pipes and wires. So they dig along through there, and as they come across the wire for some reason, they just chew the insulation off. Sometimes maybe just to amuse themselves. I don't know. Cable can be skinned by somebody driving a stake or a post into the ground. I've seen this happen too. I had a cable TV guy marking a line, and he drove metal marking stakes into the ground as he went along marking where his line was, and he drove it right through the side of an irrigation cable and skinned the insulation off the outside. So things like that happen. You might not necessarily see it, although your Mark 1 eyeball would tell you that there's a stake driven through this place where you know your cable goes. Cable cut by a shovel or a digger. Sometimes people are very neat when they do a little bit of pothole digging or something. They cover things up, put the sod back in place, and it looks like everything's normal, but they stuck a shovel in the ground there and it cut or skinned the wire. A splice that isn't waterproof. This is also a thing you can find with a ground fault locator. You normally think of nicks and cuts in the cable, but in fact, if someone didn't use a waterproof splice, or they stripped the wire back too far and it's exposed, and you have water in a valve box, or it gets wet, it can act like a ground fault, and you will find it with this type of device. So all these things are real life situations that occur, and you will need to try to find out where they were. And if you can't find them with the Mark I eyeball, then you're going to need to use some electronics. As we've done before, we use this troubleshooting chart that we often use in discussing training and troubleshooting on irrigation systems to show what part of the process this particular equipment is used in. This whole chart goes through the thing of troubleshooting a multi-wire irrigation system, starting at the controller, the source of power, working toward the field, tracking down valve boxes, looking for bad diaphragms and valves and things. But along the way, one of the things that can happen is you can identify you have cable fault. And at that point, right there in the lower left of this chart, we've identified that there's an issue with a short or open or some other thing with the cable. Then we're into checking for wire faults. We locate the cable path, and we check the cable path with the A-frame. We're talking about this using slides, but in a moment here, I have one of our YouTube videos, which I think are pretty useful for stuff like this, because it really shows you someone walking along and using the equipment and gives you any signals, what sounds like, that sort of thing. And I'll give you some more detail on how to get access to those. In the case of the ground fault locator, we have this in English and in Spanish on our YouTube site. So now we're into it for chasing this site. If you haven't been able to identify where things are and fix it or track it down with your eyeball or with a quick metering, then we're into tracking where the fault has occurred on the cable. As I said, the first thing you do, you figure out what route the cable or wire is taking using a regular locator. Hook it up and do your tracking process like normal, and making sure you know where the cable goes. You can use some inexpensive little wire flags if you need to. Mark where the cable route is. It'll make it easier for you when you're using the ground fault locator. So we're going to attach the ground fault locator just like a locator at one end of the cable, and we're going to use it to create ripples in a pool, as I call them. It's going to create a pulse voltage that causes ripples of current in the earth, and we have a tool that will help follow the ripples of current, so we're going to be able to use that to find the problem with the wire. Firstly, locate the path of the cable. Then we're going to pulse the wire with the GFL and track the ripples through the ground. And just for useful purposes for background, we're going to show you a little bit about how this works. What we have here is a device that's used much like a locator, but it puts out a very completely different signal. And I should mention that the pulse is over 2,000 volts. So if you're using this system, be very careful about touching the ground stake or the test leads while you're doing it. And when you do find the fault, you start to dig there, go back and shut the transmitter off so you don't get a shock. I had a number of users that shocked themselves. They get out there and they were so happy to find where the problem was, they started digging and forgot to shut it off. The system does put out a beep every time it pulses, so if you're still hearing that beeping and you're kind of done finding the fault, go back and shut the transmitter off so you don't get a lesson in electricity. So don't think it's going to kill anyone, but trust me, you won't do it the second time. The side view of this is when we've got the pulse going in here, the pulse is going down an insulated cable, and where the cable's been violated, it's been cut, it's been sliced open, it's been chewed off, this pulse leaks into the ground around it and sends the current back through to the ground stake, much like the tracing signal that we use with a regular locator, except in this case is one big high current pulse. And the view from the top kind of looks like a magnetic field, that when that pulse comes out of the wire, where it's touching the ground out there, it races back to the ground stake. And we're using the A-frame part of this device to be able to measure the difference in return time of arrival from that pulse. It tells us what direction the fault is. As you'll see, that turns out to be the useful part of what we're doing here. So here's another little different version of this. When the pulsar sends its test signal, it sends a beep that you can hear, and then it zaps the thing, and then at that point is when you're looking at the meter on your A-frame. You will see in the video just exactly how that works. The beep and then kick, beep, kick, and then you watch the meter on the A-frame as you walk out the path of the cable, and as you pass where the faulted location is, the meter reverses and kicks in the backward direction. It's a very intuitive thing when you see it used once, which is why I'm going to show the YouTube. All this theory is great, but you really need to see someone walk a path and have the meter kick. That's the trick that's going on here. So As the ground pulse sweeps past the A-frame, it has two probes that stick in the ground, and one gets the signal just before the other, and you'll see how that affects the needle on the meter. The meters sort of look like this. There's a little meter box that attaches to the top of the A-frame, so when the pulsing is going along, you're holding the frame out in front of you and looking at the meter, and you'll see how it kicks in one direction and another. And as you pass the point where the fault is, you will see the meter reverse. And you eventually can step backwards slightly until you're sitting right over the fault and the meter isn't kicking in any direction. Then you can turn the A-frame at a 90-degree angle and do the same thing kind of crosswise. And I will tell you, you can find these faults within one shovel width. If you do this little trick, you get the meter to center and not kick anymore, and you do it sideways, mark that spot, and you will just dig right down to where the problem is. It's pretty amazing when you see it work. So we're going to show you a little bit more physically how that works here in just a moment. I'm going to pull up this video that's on YouTube, but here's an illustration when you're looking down at the A-frame as you're following the cable path, poking it in the ground. This is what the meter looks like. You'll be able to turn the transmitter on, turn on this meter, and then make your walk down the path. So if you hold on just a moment, I'm going to switch over to this video, and we will be able to hear what's going on.
What is a ground fault? A ground fault is an unintentional grounding of an insulated wire. What can cause a ground fault? A nick or cut in the insulation. A poorly repaired splice with water around it. A current must have a path to an earth ground to be a detectable ground fault. In most cases, a cable contained in a conduit will not have a detectable fault to ground. One exception would be a PVC non-conductive conduit that is completely severed, exposing the conductors to the earth ground. A ground fault locator uses a high voltage signal to detect the location of a ground fault. The locator sends the signal down the wire, and it exits at the fault and enters the earth. The signal then returns back to the ground stake. The ground fault locator uses this returning signal to pinpoint the fault. We will demonstrate this process using the Armada Technologies GFL 3000 ground fault locator. The GFL 3000 is designed to pinpoint the exact location of a ground fault in a cable. The GFL 3000 is not intended to locate the entire path of a cable. To effectively pinpoint the location of a fault using the GFL 3000, the path of the cable must be previously determined and the wire must be in direct contact with the earth. To demonstrate that the path of the wire has been previously determined, the wire has been placed above ground. The fault is illustrated with a flag for further clarity. In cases where the wire is contained in conduit, the conduit will interfere with the locator signal and not result in an accurate reading. Isolate the cable to be tested by disconnecting it at both ends. Make sure the cable is disconnected from power, components, or anything else that could transmit an electrical current. This forces the current generated by the transmitter to exit the cable at the fault. At either end of the cable, and with the transmitter off, connect the black lead to the ground stake and push the stake into the ground as deeply as possible. Connect the red lead to the cable that is being tested. Note that if the clock is indoors, the black lead must be connected to its own ground stake where the wires exit the building. Do not use existing grounds in the building. Before turning on the transmitter, be sure no one is touching the stake, cable, or leads. When turned on, the transmitter will produce a beeping sound indicating current is being transmitted. Select low or high power as per your preference. High power will find all leaks, large or small. Low power will concentrate on larger faults. Remove the black insulating covers on the probes of the receiver. Turn the receiver on and place the receiver probes into the ground along the path of the cable. As the transmitter pulses the current, you should see the needle on the receiver kick in the direction of the fault. Watch for the direction of the initial kick of the needle and disregard the rebound kick. Remove the A-frame probes from the ground and move it in the direction of the initial needle kick along the path of the cable. Reinsert the probes into the ground and observe the direction of the initial needle kick. Continue down the path of the cable in this manner until the needle kicks in the opposite direction. This indicates a fault is between the last two places the receiver probes were inserted. Continue to zero in on the fault by following the initial needle kicks. When you are directly over the fault, the needle will cease to kick. Mark this spot for repair. Before repair, turn off the transmitter and disconnect it from the cable. Never touch the transmitter, leads, or the cable being tested while the transmitter is on, and do not use the transmitter in the rain. Failure to follow these precautions could lead to injury or death. Cables that contain many faults can be confusing as all the faults exhibit some needle kick. To minimize confusion, start near the transmitter and work your way along the cable, fixing the faults as you locate them. If you are next to the transmitter when using the receiver, the needle can kick in the direction of the transmitter. Move further down the cable, away from the transmitter to get the proper direction of kick. It is not uncommon for needle kicks to cease between the transmitter and the fault. As you move away from the transmitter, the needle response should decrease and could eventually stop. The needle will begin to kick again as it nears the fault. Small faults may be indicated by weaker kicks. To focus on larger faults, turn the transmitter power to the low setting. If you are unable to insert the probes into the ground due to concrete or asphalt, wet sponges between the ground and each probe can increase the conductivity of the frame. To bridge large obstacles, you can extend the frame by wrapping one end of wire around 1 foot of the A-frame and the other end around the screwdriver. Then use the screwdriver as you would the second probe.
Okay, I hope everyone was able to hear that okay. That is a handy illustration, much more graphic than someone describing it on slides about how this device works. And that is available on our YouTube site, and as I said, both English and Spanish. So you have access to it there. There are a couple of ways of getting to it. You can go to our YouTube channel, which is armadatech.com. We also have this little app note that's got QR codes on it. QR codes can be scanned by a smartphone. If you have the sheet like this, or you have a QR code in front of you, hold your smartphone up in the barcode scanning application, and it'll read what the website is and ask you if you want to go there. Pretty handy way of getting someone information about how they're using something. And the sheet that I'm showing in this diagram is one of the app notes that we've done. It has QR links to a number of training videos that are pretty popular. And not only do we have training videos on these products as they are, how to use them, we have shorter little 2 minutes type segments that show specific applications or techniques that are used with each of these. So very useful place to go. You can get this sheet from our blog there, as it says, armadaupdate.wordpress.com. You can also go to our Facebook page, which is easier to find probably, Armada Technologies, and you can find a link there that goes to this sheet. It also is a link for invitations to this webinar. So if you go to Armada Update, you will be able to get some pretty useful stuff. So just a couple of hints and tricks. Some of these were covered in the video, but things that are probably worth dialoguing a little bit. There can be multiple faults along a cable. Somebody starts out to find a big fault. He might find out there are a couple other gopher chews between around where the wire's been cut, for example. So you might find multiples. You just have to keep going once you find them. Steep, sharp bends in the cable, complete loop arounds in the cable can cause the pulsing to come from a direction that's different than along the cable. So you need to be aware where the path is and follow the cable or work your way along the cable to try to find the fault. Midway between the transmitter, as the video said, between the transmitter and the fault, the signal will start to fade because you're in an area where the current pulses have spread out so far through the earth that they're not kicking the meter very well. So you just keep going along the path of the cable, and the fault thing will start to reappear. If you get all the way to the end of the cable and you don't see any kicks, then you probably have no fault or a very small fault. So you can track across a paved area. There's a fair amount of moisture content still in paving material and concrete. You can put sponges, wet sponges, on the tips of the A-frame and continue to work across a piece, like a piece of concrete or patio or something, doing the ground fault locating. It's a pretty good trick. Something that I have heard anecdotally from customers is some of the systems that have a very bare copper wire for lightning type protection in the trench with the other stuff, this can upset the ability to find the fault. So you need to know if that's the kind of system you're dealing with. You may have to use a different technique. That's very commonly used in two-wire irrigation systems where volt or lightning protection is very, very carefully engineered. And in those cases, you may have an alternative like using a milliamp clamp meter to try to find out where your fault is. So resources from us, I'll mention these, and as I said, this video will be on our YouTube site later. Armadatech is our channel on YouTube. Our main website is armadatech.com. Training videos are found there. Most of our videos, long and short, can be found more easily on YouTube, frankly, and that QR code that's right above the YouTube symbol will lead you to their YouTube site. If you wanted to use that as a test, for example, you can even shoot it off the screen. So youtube.com, user Armadatech. We're on Facebook, partly just to make it easier for us to be seen, facebook.com Armadatech, and we have links there to our Armada update, which is a handy way to get there without trying to remember what all these URLs are. ArmadaUpdate.wordpress.com is our blog site. We've posted some downloadable things there. We've posted the invitations to these Friday blogs if you wanted to sign up for one, and there's a schedule of what the upcoming blog topics are, or webinar topics, sorry. And I am Jim Carefoot, and jcarefoot@armadatech.com is my email address. You're welcome to send me a follow-up on this, any questions you have, any suggestions for topics. We are welcome. We'd like to know about them for our webinars. We have some obvious topics that we know people are interested in and that are helpful, but there may be some that folks are not understanding that we don't know, and we can help figure that stuff out. So, having said that, in keeping with trying to keep it well under 30 minutes and informal, we have covered material I had on ground fault locating. This video will be posted on our YouTube a little bit later, and you can see it if you've missed it, or catch the redo of this topic done in a couple of weeks. So with that, thanks for attending with us, and hope to see you on another webinar on Fridays.